every developer in this universe write code, but it sounds really nice when someone says this developer write clean code. As Flutter framework got only Dart language to write UI code and also business logic, so everything become messy when both UI code and business logic mix up. So how do we can stop our code from being messy? So there comes the BLoC library, but we will use its lighter version, which is Cubit, that removes a bunch of boilerplate code. And this Cubit not required any kind of package to be added in the pubspec.yaml file, but that comes with the Flutter BLoC of version 6.0.0 or above. So if you don't know what is BLoC, that's the well-known and established state management library for Flutter. And that Cubit is the subset of BLoC, which removes lots of boilerplate code and makes our life easier to achieve more with less. So first, let's try to understand the structure of BLoC. Just because of using Cubit in our project doesn't mean we should avoid to learn the BLoC structure, because Cubit is the subset of the BLoC. First, we must understand the architecture or the structure of the BLoC, then it will be more easier for you to go forward for the Cubit. So if you have used BLoC in the past, you may be familiar with this diagram that you can see on the screen. So if you look at the BLoC, we have first the UI. Some events goes to BLoC and a request goes to the data from the BLoC, and a response comes to the BLoC, and some state again come to the UI. So what that means? In the BLoC we have events and states. We trigger some event from our UI sides, and then event goes to the BLoC, and the BLoC send the request to the data or actual logic which is implemented and get the response. So when the response reaches to the BLoC, it checks for the states and emit that particular state on our UI, and that states can be initial, loading, loaded or failure. So that was the structure of BLoC and the mechanism how the data flow works. And that's how we separate our business logic from our UI. But that was just the BLoC. I wanted to explain that BLoC also, just because the Cubit is the subset of BLoC, so I thought it will be more easier for you to understand Cubit after understanding the BLoC. Now you might be thinking how the Cubit will be, right? The Cubit will look something like this. A bit similar, right? But not that much. Now if you look at the architecture or the structure of Cubit, we have again the UI and some functions goes to the Cubit. Again the same request goes to the data, response, and some state is emitted in the UI. And again the states will be loading, initial, loaded or some failure state. In the Cubit we don't have any events but our direct functions. That goes to Cubit, and that Cubit is as a BLoC, as we had a BLoC that send request to the data. In our case, that Cubit will call the use cases and will get the response, and according to that, that will emit the particular state. So Cubit makes our life easier because this removes lots of boilerplate code. As I said, Cubit don't have any events but functions. These comes to the Cubit, and like BLoC, that Cubit send request to the data and get the response, and next emit some particular state like some failure, loaded or loading, or initial state if nothing is happened. Still confusions? No worry. Once it is implemented, this will become more clear to you, and with this you also can go at your own pace. And remember one more thing, this data in our case will be the use cases because we are using clean architecture, so our Cubit will not going to hold so much logic. All that real implementation is inside our remote data source implementation, which you have seen in the previous videos. So that flow will be like, let me show you in some pages. Let's suppose we have this credential pages, and go to the sign up page, go all the way down, and you will see this sign in text on which there is an inkwell. So or let's ignore this, go for this real sign up, the button container widget which color is blue, and text sign up, and on tab listener don't have any kind of method to call. From here our Cubit will call with the particular use case, and that use cases we have here. each use case has the call method. It means call that particular use case. And the method contract class is here and its implementation is in the data layer. Firebase repository implementation, and this Firebase repository implementation is taking the data from the remote data source to deal with outside world. That's our remote data source, or Firebase remote data source we can say, because we are using Firebase as a backend and the real logic implemented in the remote data source. You can see it here. It's the actual logic. So like this, that flow will works. So if you still have any confusions, let's look at this architecture again. So in the first video, that was more abstract, and in this video, I hope this is more clear to you when you look at that. We have widgets, our pages or our custom widgets. The custom widgets like the button container widget, and some pages we have the sign up page, sign in page, activity page and other. And there comes our presentations logic holder. That's in the presentation layer, and that is our Cubit directory, in which we are gonna have the Cubit. You can use the one you want, like BLoC, chain notifier or mobx, etc. And this delegate its work to use cases, and we have the business objects entities, which is in the domain layer, and the repository is at the edge between the domain and the data layer. And also not forget the call flow. I am explaining this call flow because we will trigger some event in case of BLoC, or some functions will be called in case of Cubit, and that call flow will comes from up to down, just like this. Our use cases and repository, and that's the abstract class, and its implementation is in the data layer, and that repository implementation is taking data from the remote data source, Firebase remote data source, and its implementation is again in the Firebase remote data source implementation. So that's how that flow works. Now look at our Android Studio back, and that's our remote data source, which contains the real implementation of each of the logic which we have here in the Firebase repository. That clean architecture, let me tell you one more secret of that clean architecture. Like look at that Firebase repository and also this remote data source. When in the future there is the need of any feature and our clients want to add a new feature, so it's really not going to be a headache for you to check everything and change everything. You simply have to add a simple method here and implement it in the Firebase repository implementation, and also in here, and implement it simply in here, so your feature will be added without being stressed. So that's the beauty of that architecture, and that's the secret behind the maintainable apps. So you must learn this architecture if you want to learn real app development and want to inspire your clients from your work. So now let's go for the real implementation of our Cubit. Let's go to the presentation layer, and you will see the directory Cubit here. Now right click on it and go to the new and create that Cubit class. So if you are using VS Code, so you have to download an extension of Flutter BLoC, and if you are using Android Studio and you don't know from where that Cubit class or BLoC class is coming from, you simply have to move to the file settings, and this window will appear. Close everything and go to the plugins. Come to the marketplace and search for this BLoC library and install it. So after this, you will be allowed to use this BLoC or Cubit class here. So we are not going to use BLoC but the Cubit class. So click on it, and also make sure to check this use equatable, because that's for value equality and we must use it. And name your Cubit just like this. But remember, you don't have to create Cubit directly in the Cubit directory. You simply have to create another directory for that, like we are creating the Cubit for the user. So first we will create the user, and we are also gonna have the Auth Cubit and also the Credential. This will be more clear to you when we implement 3 of them. So first we will go for this Auth Cubit. Inside this Auth Cubit, we will create the Cubit class and check the equatable and name it only Auth. Okay, and you can see two files are created in that auth directory, auth_cubit and auth_stat, and we don't have any events, but that will be in the Cubit the functions. So first go to this auth_stat, and we have already the initial auth_stat, and this auth_stat is an abstract class which extends equatable, which saves us from the value equality, and this equatable done everything for us. Now copy this auth initial and paste it 2 times, because we are gonna have the stats of authenticated and unauthenticated. Authenticated, and copy this, paste it right here, and that will be unauthenticated, like we will use in this auth_cubit to check if the user is authenticated or not. If the user is authenticated, so simply send the user to the home page, or if he is not authenticated, so he have to create his account and then send it to the home page, just like this. And this authenticated stat is going to accept a final string that will be UID, and also pass it in the constructor, make it named, so it will ask for now make it required, also make it required, and also not forget to pass it in here. That's for value equality. Now let's go to our auth_cubit, and that's our Cubit class which extends the auth_cubit generic auth_stat, and in the super it's returning the initial, like when we come to the page nothing happened initially. So now there will be the question in your mind, how these qubits will take the data from these use cases. Let me show you how. As these use cases are the classes, so we will take the instance of them in our Cubit class, and then we will use them just like this. So in the auth_cubit we are gonna have sign out user use case and name it as it is sign out user use case, and the next we are gonna have is, and also this will be final, is sign in use case, because we will check for the user is authenticated or not, is sign in use case, final get current UID use case, get current UID use case, and that current UID is for ensuring that the users exist or not, that there is the user ID or not, and simply pass all of them in the constructor and make them name parameter just like this and require them. The last one is remaining, go press alt enter, add required, and just like this. Now we are gonna have some methods in this Cubit class, and these methods will call in our UI, and that flow will work like this, like the UI call any function, this comes to the Cubit call the use cases, that goes to the repository implementation, remote data source implementation, and finally in here the remote data source implementation will call the real logic, and from here there's the data that will send the response if there were some error, so this will emit the state of error or unauthenticated in this auth_cubit, or if it was loading, so it will show the circular progress indicator. So now right after this Cubit constructor we are gonna have the method of feature void. Its name will be apps started, like when the app started this will check for the user is signed in or not, and put parentheses here, this will accept build context and async and open body. There will be try catch just like this to handle some error if it occurs. Now inside the try method we will do boolean is sign in equal to await is sign in use case dot call. We are calling our is sign in use case, that use case and that method from it. So now again go to the Cubit method, and here after this there will be a condition if is sign in was equal to true, like if our is sign in method returns the true, like if the UID was not equal to null, it means the user is sign in. So we will do final UID equal to await get current UID use case dot call. This will give us the current UID of the user, and here first we are checking for if it's not equal to null, then get it, and after this we will emit any state that will be our authenticated state, and this required the UID, and that UID will be the UID of the current user which is signed in. And in the else method we will emit the unauthenticated state, and if there is some error, so we will also emit that unauthenticated state. So that method will be just like this to check for the user if is signed in or not. Now let's go for the next method. That will be our method. Its name will be feature void and logged in, and remember that's not the login or the sign in, but that's the login. Let me show you the functionality of this, how this will works. There will be first the try and catch block, and inside this try block there will be final UID equal to await get current UID use case dot call, and emit the authenticated state and pass the UID in here, and in the else or in the catch emit the state of unauthenticated, just like this. That is only for making sure that the user is authenticated. So if there was no ID and that ID was null, so this unauthenticated state will be emitted, and you will see this method in action later when we call this in our UI. And the last method of this auth qubit will going to be feature void logged out async open body, and again there will be try catch open body, and inside this try there will be directly await sign out use case dot call, and then emit the unauthenticated state, and in the else condition also emit the unauthenticated state. Like when the user call this logged out method, so he will be signed out to the application, and we will emit the state of unauthenticated, so he will back to the credential pages, just like this. So there were only 3 methods: logged in, logged out, and the app started method, and that was our auth qubit. Now let's go for this credential qubit. Create the new qubit class in here, make sure it's equatable, and name it to credential. Okay, open it. So we got credential state and credential qubit in here. Now copy this and paste it 3 times, because we are gonna have 3 states. One is initial already created, and this first one will be loading, credential success. So that credential initial will not be just like this, that will be failure, and is not going to accept any kind of parameter, like there is nothing to load and no stream data, but the 2 feature methods that we have to call, and only the states will be emitted according to the situation. Go to the credential qubit, and inside this we are gonna have the use cases of final sign in user use case, sign in user use case, final sign up use case or sign up user use case, and pass them in the credential and make them name parameters required. And right after this there will be only 2 methods that will be of sign in user and sign up the user. So first we will create the sign in user method, that will again be the feature void sign in user, and parentheses, this will take string email and string password, or you also can pass the direct user entity and simply access these only email and password here, but I am passing only email and password because I only want this in my sign in case. So I will make them required just like this. It will be async open body. First in this method we will emit the credential loading. Like firstly when this method calls, so this will be the loading state if the data has not been loaded yet, and then we will try and catch, and inside that try block we will await the sign in use case dot call, and this takes the user entity, pass the user entity in here, and here it accepts all of the fields, so simply only access to the email, pass the email here, and access to the password and pass the password here. Right after this, emit the stat of credential success, and if there were some error, so emit the credential failure. And we also should check one more exception, that will be on socket exception, catch this and also emit this credential failure. And right after this, copy this is sign in method and go for here and only change its name to sign up user, and this time while signing up user to the application there will be the need of more data like email, bio, username, just like this. So we have to put user entity or only user and also make it required, so we will pass in that call user, just like this, and then the whole method will remain the same. First emit the credential loading, if the data was loading try for this, if the sign in method calls and it's success, so emit the success, if there were some socket exception emit credential failure, and if it is not and some other failure exception, so then also emit the credential failure. We are checking these exceptions here in order to avoid our application from being crashed in the middle, because that will be low user experience in our app. So now it's time to go for this user Cubit. Inside this user Cubit we will create the Cubit class that will be only user. Open it, go to the stat, copy this initial stat and paste it 3 times. This will be user loading, user loaded and user failure, and this user loaded will accept the final list of user entity, because that will be the list of the user when we get all the users. This will be users, and also make sure to pass it in the constructor, make this required just like this, and also pass it in here for value equality. Now we are done with our user stat. Go for this Cubit, and inside this we are gonna have the use cases of final update user use case and update user use case, final get users use case and get user use case. In here we will get the users and update the user. You may be noticed we are avoiding to use or we are not using the create user method, just because if you look at the real implementation in the remote data source, come here and in the sign up method, when our user is created in the authentication tab, after calling this create user with email and password, we will take the email and password from the user. When this process completes, so we are checking for the UID of the user. If it was not equal to null, it means the user is signed into the application, so create the user with the user. So his all of the data will be created in our Cloud Firestore database. So this sign up method does everything for us. When we call this from the credential stat, this sign up, so this will done the job for us. So that's how this scenario is. Now move to the user Cubit again and pass these 2 fields in the constructor, make them named and require them, and there will be 2 methods as we have only 2 use cases. The first, that will be future void and its name will be get users, and this will take the user entity, required user entity, only user, and assign as this method is a future. So open body, inside this we are gonna have to do emit the state of loading or user loading, and after this there will be try catch blocks, try and catch on socket exception. This will not be here, but on socket exception catch, this open body emit the user failure, and also the catch method emit user failure, and inside this try method we will do final stream response as this get user use case return type is stream list of user entity. So this scenario will be a bit different. Stream response will be equal to get users use case dot call, this takes the user entity, pass the user here, and after this we will do stream response dot listen stream subscription list of user entity. So we are listening to the stream and that event will be our users. After this, inside the stream response we will do emit the user loaded, not loading, loaded, this take the list of users. So pass this list of user from this, which is returned from the stream response after listening to the stream. So here we are calling that use case and simply listening to the stream and pass these users from there inside this loaded, and according to this our data will come live data, like when some changes occurs that will be real-time changes in that data. Now that was it for our get users method. Now our get update user method will be different from it. Let's go to the credential Cubit and copy this, because the update user will be our future method, so it will be similar to this. Paste it right here and make sure to remove this loading state from here, and this will call await the update user use case at accept the user entity. That will not be the credential success here, remove it from here. That's only for updating the user, and copy this failure, paste it here and also here. So that was our update method. Let's change its name, update user. So that's how our update user method will be. So first we have created our auth qubit, and we talk about the qubit and BLoC also. This qubit will ensure if the user is signed in or not, and it's also performing two more functions. And in the credential state we have some states of failure, success, loading, initial, and the qubit we are calling the sign in user, sign up. And as I said, the Cubit is not going to hold so much logics, but that delegate its work to use cases, and you can see it in action now. And lastly we have this user qubit, update user, and get users. So that was our qubits of the user. You also can take this code from the written tutorial and also from the GitHub. And in the next video we will go for the dependency injection. I will show you what the dependency injections and why this is useful to use in your application. And this we will also call these methods in our pages, and I will show you the actual work of it, and then you will realize how that flow is connected and how this works. So I hope this video was helpful. If so, show some love in the comment section, and also let me know if something is not clear to you. And with this, be sure to subscribe and hit the bell icon to make sure you get notified whenever the next video is uploaded. And also follow eTechViral on Instagram to improve your coding skills on daily basis. For now, goodbye, and I will see you in the next video.